Right. So they say using the grid on page 11, draw the graphs of sine 2x, cosine 2x, where x is greater than equal to 0 but less than equal to pi. And you know pi is really 180 degrees. So basically x is greater than equal to 0 degrees but less than equal to 180 degrees, basically. Right? So we have to plot sine 2x and cosine 2x on the graph. Now it will just be basically half of a sine x or a cosine x graph. And not half, but like basically half in the points, I should say. So like where a 90-degree angle would be in a sine x graph, the angle will now be half of that for sine of 2x, basically. Right? Um, because consider sine x, right? If x is equal to 90 degrees, that is the angle there, right? You have to consider sine of 2x. Let's say this angle is 90 degrees. Then 2x would therefore be equal to 90 degrees. Therefore, x will be half of that, which is 45 degrees. So that's why the graph kind of would be closer together. Half, in other words, right? So I'm going to plot the sine graph first. Zoom in here. Um, when x is 0, y will be 0. So that will be the first point here. Actually, I got plot the cosine graph first. So this is when x is 0, y is 0 there. Then it will pass through this part here, which would have been 90 degrees in a normal cosine x graph. Then 1 will be, well, negative 1 will be pi over 2, which is here. Then it will pass through this point here. And then the complete revolution will be for when you have pi, right? And then you just connect it. Well, it should have passed through that point. Something like that, right? This is y is equal to cosine 2x. Now we have to plot sine, so I'll put this one in blue. So it will start from the rest position here, which x is 0, y is 0 there. Um, this would be the angle here when pi over 4, y will be 1. It will pass through this point here, this angle here. It will come down to 3 pi over 4, that point there, and it will go up to pi. Um, I'll draw the curve like that. Like that. So this is y is equal to sine of 2x, right? So that is the graph. Now they say hence or otherwise solve this equation. Now in order to solve this equation, we want to write everything in terms of sine or everything in terms of cosine, right? So you could do it that way, or you could just look at the graph as well, right? I would solve it using the algebra method, right? So we have sine 2x is equal to cosine 2x. I'm going to divide everything by cosine 2x. So sine 2x divided by cosine 2x, that would be equal to cosine 2x all over cosine 2x. Now if you have cosine 2x divided by itself, obviously that will cancel off and you will get 1. Right? Now sine 2x divided by cosine 2x, that will give you tan 2x. And therefore that will be equal to 1. Because we know the identity sine of x all over cosine of x is equal to tan of x. So you can apply the same principle there. So you have tan of 2x is equal to 1. 2x is equal to tan inverse of 1. And if I make a sketch of this, tan 2x is equal to positive 1. Which part would tan be positive on a graph like this? Tan must be positive in the third quadrant. So you would have a line like this here. This is the third quadrant. So tan is positive there. Alright, so you have to find the angle from the positive x-axis, which would be here. So that would be, this would be one of your solution. This would be greater than 180, and then this here is the other solution. Right? But it would be basically the same. So we have two x is equal, make sure the calculator is in degrees. Tan inverse of 1, I am getting 45 degrees. Right? Which would be here. Here would be 45 degrees. Right? The two solution you would have for this would be theta degrees and theta, well, pi plus theta. Right? So these are the two solutions, because remember here is 180, from here to here is 180. Right? The angle that this line makes with the x-axis for here is 45. This alone is 45. So you have 45 degrees, and then you have pi plus theta, which is pi, which is 180, plus the 45, 180 plus 45, which is 225 degrees. So therefore x would be divide these two angles by 2. But before I do that, I can write them in terms of pi. So 45 degrees in terms of pi is 45 divided by 180, which is basically 0.25, which is basically pi all over 4. And 225 in terms of pi radians would be 1 1/4, or 5 pi over 4. Now x would be dividing pi over 4 by 2. So basically 1/4 divided by 2 is 1/8. So you're going to get pi over 8. And then 5 over 4 divided by 2. You're getting 5 over 16. This is 5 pi over 16. And that is my solution there. Right? Understand this, right? Right. So Part B, using appropriate double angle formula, derive sine of 2x. This is pretty simple. You get this from the formula sheet as well. I would not be able to do this question tonight. So I will just show you the formula sheet one time for that. So this is the double angle formula here, right? Using that, for sine of 2x, I'm going to split up sine of 2x into x plus x. Well, 2x into x plus x. So I have sine of, well, a plus b from the formula would be equal to sine of a cosine of b plus cosine of a sine of b, right? So you're going to have sine of x plus x, and that will be equal to sine of x cosine of x plus cosine of x sine of x. Now this is basically the same thing added up here. This is sine of x cosine of x plus itself, the sine of x cosine of x. I can interchange these two since we're multiplying them. If you have sine of x cosine of x plus itself sine of x cosine of x, you're going to get 2 sine of x cosine of x. So this is the double angle formula there for that. This is for sine of 2x, right? Sine of 2x. Understand the solution here, right? Right. And then let's say prove this identity here. So to prove that identity there, I would use the left hand side. So let's say hence, right? So since say hence, I could use the answer from above, that is this, and substitute it here. So I have I want to write everything in terms of sine and cosine. So I could write one as sine squared x plus cosine squared x, right? Because that's the same thing as 1. Because sine squared x plus cosine of x, cosine squared x is equal to 1. That is identity, right? Plus 2 sine x cosine of x. This is all over sine of x plus cosine of x. So what I'm going to do here now, I can write sine squared x plus 2 sine x cosine x plus cosine square x, and I'm dividing this by sine x plus cosine x. Now you have to visualize this and look at this. You have one term squared, sine squared x here, another term squared, cosine squared x, and then you have 2 times the product of those two terms. So this is basically if you have x squared plus 2, x plus 2 squared, I should say, x plus 2 squared, right? How do you expand this? You say this is x squared, you square the first term, plus, you say 2 by x is 2x, multiply that by 2, you'll get 4x, and you square the last term, you'll get 2 squared is 4, right? So similarly, this can be written as sine x plus cosine x squared, because that is the top, right? All over sine x plus cosine x. Because if you square the top, you square the first term sine x, you get sine squared x, as what we have here. You say cosine x times sine x is sine x cosine x, and multiply that by 2, you get 2 sine x cosine x. You square cosine x, you get cosine squared x, like what we have there. Right? This is the same thing as saying sine x plus cosine x times sine x plus cosine x. You multiply it by itself basically because you had it's the same thing as it squared, right? This is all over sine x plus cosine x. I put it in brackets so you can see how I canceling it off. This cancel off with this, and I will get 1. 1 times sine x cosine x is the same thing as sine x plus cosine x. 1 times sine x plus cosine x is the same thing as sine x plus cosine x. And this is what we have here. So understand this proof, right? Alright, so I'll just go to the last one here, which is part C. So they said using the letters P, Q, or R, write an expression for each of the following trigonometric ratios. So you have to find sine theta. Now this is CXC kind of thing here. You just use SOHCAHTOA to right? SOHCAHTOA. So sine is opposite over hypotenuse. So the opposite, first you label it. So this is the hypotenuse because it's opposite the 90-degree angle. Opposite the angle theta is called the opposite side. And this is the adjacent. So since sine theta is equal to the opposite all over the hypotenuse, you're going to replace the opposite side with the p because p is in the opposite side all over the hypotenuse, which is q. So p over q is sine theta. Simple. Cosine theta is adjacent all over hypotenuse. You're going to replace the adjacent with r all over the hypotenuse, which is q. So is r over q is my answer. That's 2. Now they say using your answer in C1, determine the value of sine squared theta plus cosine squared theta. And recall that sine squared theta is equal to sine theta in brackets squared. That will be the same thing for cosine squared theta. So cosine squared theta would be equal to cosine theta in brackets squared. Right? So to find sine squared theta, you're going to basically square the p all over q, and to find cosine square theta, you're basically going to square r over q. So to get sine square theta plus cosine square theta, we have to add these two. So you get p squared over q squared, because you have to square the top and the bottom, plus r squared all over q squared. The denominator is the same here, so you're going to get p squared plus r squared all over q squared, and this would therefore be equal to 1, right? By the identity that sine squared theta plus cosine squared theta is equal to 1. Right? So that is equal to 1. So determine the value of this. But based on the identity, we know that this would be equal to 1 because sine squared theta plus cosine squared theta is equal to 1. But over here, if we apply Pythagoras theorem as well, we know that the hypotenuse squared, which is q squared, will be equal to the sum of the other sides where each term is squared. So that will be equal to p squared plus r squared. This is Pythagoras theorem. So we have p squared plus r squared on top. So that will be equal to q squared. So we have q squared divided by q squared, since p squared plus r squared is equal to q squared by Pythagoras theorem. So q squared divided by q squared cancel off, you're going to get 1. So you still get the answer of 1. Understand this, right? Alright, so we're going to try the last one here. Now. Prove that tan A plus 1 over tan A is equal to 1 over sine A cosine A. So I will take the left hand side here. This is the left hand side, and allow it to be equal to the right hand side. So I write in tan A in terms of sine and cosine. So this will be sine A all over cosine of A. So I have sine A over cosine of A plus 1 all over sine A all over cosine of A. So 1 divided by sine A cosine of A, you bring this on top and you had a flip. So you're basically getting sine A over cosine A plus cosine A all over sine A, because when I bring that on top, you had a flip. Now you find the LCM between cosine of A and sine of A, you're going to get the product of sine A cosine of A. Sine A cosine of A divided by cosine of A will just give you sine A, and you have to multiply by the numerator here, which is sine A. So that's why I'm putting this in bracket. Put your plus sign. Sine A cosine A divided by sine A will just give you cosine of A, and you have to multiply by the numerator here, which is cosine of A. So sine A times sine A is sine squared A, plus cosine A times cosine A is cosine squared A, and this is all over sine A cosine A. Now sine squared A plus cosine squared A is equal to 1, and this is all over sine A cosine of A. And that is basically what we had here. Right, so you understand the solution for the 25 and the 24, right? Trigonometry.